When you hear the word blockchain, your mind probably jumps straight to Bitcoin or Ethereum, right? These massive public ledgers that anyone can join. But for most businesses, that total openness is, well, it's a non starter. So, what happens when a global corporation needs that same kind of trust and security, but behind closed doors? We're about to dive into two really powerful answers: Hyperledger and IOTA. And yeah, this really is the heart of the problem. A public blockchain's biggest strengths, being totally transparent and open to the whole world, are often a company's biggest weaknesses. I mean, businesses run on confidential data, on controlled access. They can't just splash their sensitive supply chain info or trade secrets onto a public network for all their competitors to see. No way. All right, so here's our game plan. First, we're going to dig into why businesses even need a private option. Then, we'll step into what's called the Hyperledger greenhouse and take a close look at its star player, Fabric, including its really clever security model. And finally, we'll totally switch gears and look at something completely different: IOTA's Tangle, which is a ledger that, get this, doesn't even use blocks. So, you might be asking, why can't a group of banks or a giant logistics company just use something like Bitcoin? It's a fair question. And the answer really comes down to a few core things that businesses absolutely need, things that public blockchains were just never built to do. At the end of the day, it really boils down to these three things: privacy, because you're dealing with trade secrets; scalability, because you need the horsepower to handle a massive number of transactions without getting killed by fees; and of course, control. You need airtight control over who gets a key to the front door. Public ledgers, they just don't operate in that world. Okay, so to solve this, in steps Hyperledger. Now, it's really important to know that Hyperledger isn't a company. It's not a cryptocurrency, and it's not one single blockchain. It's hosted by the Linux Foundation, and it's better to think of it as a collaborative project, kind of like a greenhouse where all these different business-focused blockchain solutions are grown and developed. And just look at this. You can see it's not just one thing. It's an entire ecosystem. You've got different ledgers like Fabric and Sawtooth, plus a bunch of libraries and tools to help you build whatever you need. It's a full-on toolbox for enterprise blockchain. So for our deep dive, we're going to grab the most popular tool in that box: Hyperledger Fabric. So what's the secret sauce here? How does Fabric actually deliver the privacy and control that businesses are screaming for? Well, it basically gives you a blueprint to build your own private digital consortium. Think about it. A group of diamond miners, cutters, and jewelers all want to track a gem from the mine to the store. They need a shared, trusted record, but they definitely don't want competitors seeing their private deals. Fabric is tailor-made for that. Let's look at the pieces that make it work. First up, you've got the ledger itself, but it's not just a simple list. It's actually two parts. You have the transaction log. That's the permanent, unchangeable history of every single thing that's ever happened. And then you have what's called the world state. Think of this as a database. It often uses things like LevelDB or CouchDB that shows you the current value of everything. It's the what is true right now part, which makes it super fast to check on the latest status of an asset. All right, next we've got the peers. You can think of these as the workhorses of the network. Each company or organization in the consortium runs its own peer nodes, and these peers have two main jobs. They hold a copy of the ledger, and they run the smart contracts, which in the world of Fabric are called chain code. Now, this is where things get really clever. This is Fabric's elegant answer to privacy: channels. A channel is basically a private meeting room on the network. Going back to our diamond example, maybe the miner and the cutter create one private channel to secretly negotiate the price of a raw stone. Meanwhile, the cutter and the retailer have a totally separate channel to discuss the finished jewelry. It's a brilliant way to keep data siloed off, even on the same network. Okay, but how do you keep everyone's books in sync? How do you make sure everyone agrees on the order of events? That is the job of the ordering service. Think of it like a notary. It gathers up all the approved transactions, puts them in a strict sequence inside a block, and then broadcasts that block out to all the peers on a channel. This is what creates that consistent, single source of truth for everybody. All right, we've got the structure for private deals. But how do you even get in the door? Who's checking IDs? For our Diamond Consortium to actually work, you have to be 100% sure that the member who calls themselves a miner is really a miner. This is where Fabric's really sophisticated identity system comes into play, and it's what makes the whole thing trustworthy. It all kicks off with something called a certificate authority, or CA. Just like a government issues a passport to prove you're a citizen, the CA issues verifiable digital certificates to every single person and component on the network: users, peer nodes, you name it. This is the cryptographic root of trust. It's how you prove you are who you say you are. But hey, having a passport doesn't mean you can just walk into a top-secret military base, right? You also need permissions, and that's the job of the Membership Service Provider, or MSP. The MSP is the component that looks at your certificate and says, okay, this identity belongs to an admin from Organization A, and they have permission to do X, Y, and Z. It's what translates your identity into your actual rights on the network. And what's really cool is that these permissions actually work on two different levels. Think of the local MSP like the rules for a single office building. It defines who the building manager is, who has keys to what rooms. Then you have the channel MSP, which sets the rules for the entire corporate campus. It says who's allowed to enter different buildings and attend those private meetings we talked about. It's this two-tiered system that gives Fabric such incredibly fine-grained control. So that's Hyperledger Fabric in a nutshell, an amazing tool for when a known group of businesses needs to work together. But what if you're dealing with a totally different world? A world with maybe billions of tiny little devices that don't necessarily trust each other. For the Internet of Things, a project called IOTA decided to completely rethink the ledger by getting rid of the blockchain altogether. The key problem IOTA is trying to solve is this. Imagine a future where your electric car needs to make dozens of tiny automatic payments for just a few seconds of electricity at different charging stations. On a traditional blockchain, the transaction fees would literally cost more than the electricity you're buying. It just doesn't work. So IOTA was designed from day one to solve this by getting rid of fees entirely. IOTA's solution is pretty radical. It gets rid of blocks and it gets rid of miners. Instead, it uses a structure called the tangle, which looks more like a web of interconnected transactions. The rule is simple, but it's brilliant. Before your device can add a new transaction to the web, it first has to pick two older transactions and confirm that they're valid. You essentially pay it forward. Your transaction helps secure the network, and future transactions will do the same for yours. This comparison just lays it all out, side by side. Blockchain is a linear chain, approved by miners who need fees as an incentive. The tangle is a web-like graph, where approval is done by new transactions, which means there's no need for fees. And maybe the most crucial difference is this. In IOTA, there's no distinction between users and validators. Everyone who uses the network also helps secure it. So what's the big takeaway from all this? Well, we're seeing the idea of blockchain splinter into a whole range of specialized tools. The old dream of having one single ledger to rule them all is kind of fading. What's replacing it are these precision instruments. You have controlled frameworks like Fabric for corporate alliances, and you have these radical new designs like IOTA, built for the fast, chaotic, high-volume world of smart devices. And that leaves us with a really fascinating question to think about. As more and more of our physical world gets connected, from our supply chains to our smart homes, which path is going to build the future? Will it be these private, permissioned consortiums? Or will it be open, feeless networks of machines talking to each other? Or maybe, just maybe, it'll be some combination of both. The answer is still being written.